Hi, I'm going to talk today about building the Stonehenge using Gall's law. My name is Fabricio Buzeto and I've been coding since 2002. I worked my fair share in big companies and small as well. Also, I did my time in academia and had my PhD. That's why you're going to see a lot of references in my slides. I've been working with startups since 2011 and this has been my love since then. And what I'm going to share today is a bit of my past experience and what I've been currently learning about building this type of products in this kind of environment of startups. So let's start talking about what is Gall's law. Gall's law states that a complex system that works is invariably found to have evolved from a simple system that also worked. And a key word here is the word evolve. How do we perceive a complex system evolving? Usually when we think about this, we think about adding features, starting with something that works and just keep adding features and features that will remain with this working. But usually a complex system evolves and starts from a very initial state that usually doesn't work or we don't know that it works. So that's where comes the second and important part of the Gall's law. It's what is this simple system? When I think about Gall's law, the first and better example that I can find is Game of Life from John Conway. So if you are not familiar with this classic example in computer science, you have just 3 simple rules. And with 3 simple rules, you can create very complex behaviors. When you look at the results and play around with John Conway's Game of Life, you learn that most of the initial states that you have are not stable. They die out and you have nothing left. But if you work well and you try it out, you can find very complex and beautiful results like this. Gall's law also states that this simple system may or may not work. And that's something that we should be familiar with, because knowing what works or not, it's key when you're selecting that simple system. So knowing what works means start with thinking about it. And when we talk about software, a software that works is a software that fulfills its purpose. And the purpose of a software is many. A software can exist to improve learning or to prove something or to help explore some context, some problem. A software can exist to help politics within an organization. Somebody that's trying a promotion or trying to prove that something that they believe is true, it's happening. But usually most softwares, they are focused on business, helping the business advance or go forward. So I'm going to stick with that. Also, every software has a client. This client can be the team that is using that software to help them with some task, can be the company itself, can be a sponsor that's paying for that software no matter what, but usually is a user, somebody that's really interested of having that software solving their problem. Gall's law also states that a complex system designed from scratch never works and cannot be patched up to make it work. If you do so, if we start a complex system from scratch as a complex design, you have to start over with a working simple system. That's why we should start simple. And I'll start with some examples of myself. I'll start with Qualcanal. Qualcanal was a startup that I worked back in 2012, and we did social TV analytics. Basically, what we did was to watch for a Twitter stream about TV shows and generate intelligence based on that data. And when I got into the company, our infrastructure was very simple. We plugged it into Twitter API, processed the data using Django, and fed to a MySQL database. It worked well. We just had a few shows, but we stumbled on our first barrier, which was the limits of the Twitter API. So we had to switch to a Twitter API roles, which was data sift. So it allowed us to address the whole Twitter comments about a TV show. And since we had just a few shows, it also started small. So our average tweets per day was just 10K and our peak was 5K. When we had these peaks, our application would just freeze. And that was not nice. I knew that our infrastructure was not the best. It was the simplest we can do with our purpose, but was not also available for us to just start rewriting everything from scratch. So what we did was, let's just try to scale this. And we did. We scaled first our Django application, and this helped us to increase our volume. we reached 5K tweets per day. Then our database got into the way, but we managed to also increase, doubling our capacity until we knew that we reached our limit. It was impossible for us to increase any longer without just having a very complex and difficult to maintain database and code base. So what we did was, let's go for a final infrastructure. So we studied, we chose Apache Storm back then, and we did some experiments, and we started small. We migrated one simple metric from our Django application to Apache Storm, and over 6 months, we migrated one metric at a time to this new application, while the other application was maintained and also works. Until the end, we managed to migrate everything, and we reached more than 1 million tweets per day. And I remember our peak was 50K tweets per minute, even though we never had any issues with load anymore. So this got me thinking that this kind of approach, where I try to stretch the application and the architecture as much as I could until it hurted, was the best approach for this kind of situation. And this is how I started when I got into bxblue. So I was since the beginning in the company. Our first MVP was just an unbound page pointing to a Google Docs. Of course, it won't last for much. When we started having too much load for us to handle by ourselves, I started building a Rails application that helped us handle our requests from the clients. This Rails application eventually replaced our Google spreadsheets, and we placed it as an ERP to handle our client's pipeline. This infrastructure grew, and eventually we had to have our own database to handle our clients' requests, and we chose MongoDB. So on each step, architecture changed, but not very much, just a little bit at a time. And the purpose of each step was to answer a question. So first was to answer if the main purpose of the company could be fulfilled, then if we could sell anything, if we could do it faster, and finally, if we could do it properly so we could have a bigger team handling these requests. What these have in common, these two applications, is that both of them are monoliths. Why monoliths? The main reason? Because they're simple. Monoliths are simple to develop, simple to test, simple to deploy, and simple to reuse. They can be simple to scale as well, but usually when you think about monoliths, you think about the drawbacks. And the main drawbacks of a monolith is that they are hard to scale. Hard to scale their tests, how to scale the team to avoid that many people are working on the same thing, how to scale the deploy. You can have a faster deploy. It's hard when you have a very large code base. How to scale your stack so you can have new technologies living with legacy ones, and how to scale changes when you have lots of changes happening at the same time. So let's talk about how bxblue handled this type of scale. So our Rails application was very simple, but it also relied on a lot of external services. We had more than 15 of them plugged on our application, helping us do our job. Over time, what we did was just go async. So asynchronous communication was handled using Sidekick to handle our jobs and our job queues. So this managed to have us scale it at a very fast pace. And what helped us was not this architecture per se, but also how we did our development. And the first thing that we did was we always automated our tools, because you don't have to trust yourself. You have to trust your code, and you have to trust that on every change that you make, things are still working. So you have to automate your tests, automate your code quality, automate your deploy, and automate your monitoring tools. Your tests, so every time you deploy something, you know that your code is still working. Automate your code quality checks. So every time somebody is code reviewing, they are not checking the same things again, so they can miss something out. Automating your deploys, so people don't have to think about all the checklists over and over again. And automate your monitoring, so you know that if something goes wrong, you'll be notified. When you're done automating, what you should worry about? You should, on your tests, you should worry about your unit tests. You should worry about things that are in common with your tests, so you don't have to rewrite them every time, and you can better maintain. integration tests, not only internal, but external as well. So you know that when some external tool changes, you know if it broke something. And about speed, if your tests take too much time to run, you avoid running them. Your code quality, so you can control coverage, and you know that you have a blind spot. Your linter, your code quality, so you know that your team is not checking something that a machine can help them do. And your security, so you know that if you introduce something bad in your code. In your deployment, you have a very good CI/CD pipeline stable, you have a source control, and you have a cloud pipeline that controls all your servers. And finally, monitoring. Monitoring your errors, your servers, your logs, and your user journey. In our case, we have a Rails application, so we use most of the Rails ecosystem for that. But we're a monolith, and unlike Qualcanal, our problem was not scaling the application to handle users, but scaling our application to handle its context. As our monolith grew, we started adding more and more context to our monolith, and this started to slow us down in our development. So that's where we complicated things. So before I started talking about what we did, let me talk about the options that we have if we wanted to avoid the monolith. So basically what we have here is a distributed system. And a distributed system mainly is something that runs on multiple servers, and these applications, they manage some kind of data. We have many architectures available besides the monolith. We have the microservices, that they are simple, self-contained, they are loosely coupled, they are single-focused, and they are services. They are connected by themselves. We have the proposal of the Citadel by GHH. That's a large self-contained monolith that's supported by small, single-focused, problem-specific services that handle what the monolith cannot handle by itself. We have also the microservices that are kind of more hungry microservices that people from Uber are starting to experiment. They're simple, they're self-contained, they're context-focused as well, but they're multi-purpose services that try to engulf more context in their services than just a microservices does. And what did bxblue? Okay, so we had our architectures as I presented before. Just out of simplicity, I'll consider my application as this small box with Sidekick and MongoDB, this square. What we did when we had to start and add that new context, we decided we're going to create a new application. So instead of building this new context in the same monolith that we had before, we are going to extract it and build its own application to handle it. And it did well. The development time was great. Integration with the legacy monolith was easy. And we started adding more services and more external applications to it. Then we did it again. A new context appeared. We built a new application to that context. More services aggregate to it. And it did so well that now we have more than 6 applications in our park. And that's what we call the Stonehenge. So the Stonehenge is a distributed system strategy, just like the others. We call it as one step further into the microservices. So it's a simple, self-sufficient, context-focused, service-enabled application. The difference here is that we don't think about services only. We're thinking about applications. So they are self-sufficient because they work by themselves. They don't need the other applications to do their job. They are context-focused, which means they can handle that focus very, very well. And they are service-enabled, which means that other applications can integrate with them so they can scale, but they don't need them. They can work that by themselves. And by the law of conservation of complexity, complexity has to go somewhere. So it doesn't matter which of these architecture I choose. Every application has an inherent amount of complexity that cannot be removed or hidden. So we chose the Stonehenge because it was the better way for us. But complexity is still there, mingled in the applications, the way the whole park is connected, just like microservices or microservices. What I'm trying to avoid here is not complexity as per se, but that code. When you see the statistics, something around 5 and 30% of what we code, they are not used. And when you think about startups, 70% of startups will fail. So the code that they build will never be used again. And what I'm trying to do is to make sure that the code that I'm building, they are the best ones for that purpose, and they are trying to help the companies that where they live to move forward, and they are used. So summing up, if you have to take something from this conversation, is that Gall's law works. A simple system may or may not work, but a complex system designed from scratch never works and cannot be patched up to make it work. So a complex system that works is invariably found to have evolved from a simple system that worked. And if you're into a complex problem, start small, start simple. That's the way to go. And don't trust yourself. Trust the machine. Automate your tools, your tests, your code quality, your deploy, your monitoring. This is the best way to ensure that every time you change, things are stable. If things are going to break, and if you know when they're broken, you can fix it. So build a very good automated tool set to help you do that. And lastly, why not try the Stonehenge? It's the simplest solution is usually the best. So in the end, everything is just distributed systems. Decision making is hard and things will change. So this is another option in your toolset. So thanks. And I'm happy to hear your opinions and what you thought about what I'm showing here. To have any comments in the video, on Twitter, just reach me out. Bye bye.